Hi everyone, this video is for Bayesian networks. We are going to explore two concepts, the D-separation and variable eliminations in this video through solving problem 1 in the assignment. First, let's take a look at the problem statement. Given the nodes in the network and the assumptions of independence, we need to draw the directed acyclic graph, which is also called DAG. It is also required to predict the last variable in networks from marginal and pairwise conditional probabilities. There are 5 conditions given as shown in the table. We will review two concepts that will be used to solve the problems, D-separation and variable elimination. Then we'll go through each of the 5 conditions. D-separation is a criteria for deciding from a given causal graph whether a set of variables x is independent of another set y given a third set z. Z can be an empty set as well. So how do we know that x and y are conditionally independent given z? The answer is that if x, y are separated by z, which means that all the paths between x and y are inactive, then x and y are independent. And if there is any path between x and y that is active, then x and y are not independent. And so we need to know how to determine whether a path is active or not. We'll check that every 3 connected nodes on the path. So the 3 connected nodes are called a triple. If all the triples in the path are active, then the path is active. Any inactive triple in the path will make the path inactive. As shown in the table on the right side, there are 3 types of triples: causal chain, common cause, and common effect. Both causal chain and common cause, the triple is active if the middle node is not given, and it is inactive if the middle node is given. But in the common effect case, which is the reverse case, only when the middle node is given, it is active. When the middle node is not given, then it's inactive. So to summarize this 2 steps for the D-separation, one is to look at all the paths and then determine that if all the paths are inactive, so we can know that whether x and y are independent. Another concept we need to review is the variable elimination. We'll use an example to explain this. As shown in this DAG, we know that the initial factors are the marginals of A, marginal of C, and the conditional of B given A, C. We have a choice of ordering. We'll use the order of A, C, and we will first eliminate variable A and then eliminate C. So first we'll get all the factors that has variable A, which is marginal of A and the condition of B given AC. Then we can have a new factor of F1BC equal to the sum over all the status of A of the product of the factor that has variable A in it. So we'll remove 2 initial factors, margin of A and the margin of and the condition of B or given AC. And then we will have a new factor that is F1BC. So in the same way, we can get the factor of F2B, which only have one variable B. And then after this, we can do the renormalize to get the distribution of variable B. So now we have reviewed the D-separation and variable elimination. Let's look at the 5 conditions in the problem statement. In condition 1, there are 3 variables in the network x, y, and z, and the variables are independent x and y. So to meet this requirement, the one possibility is x, y, and z, they are all independent. Another possible is the DAG as shown in the circle 1, the common effect. Now look at condition 2. Condition 2 have one more requirement, that x and y are not independent given z. So the only case that is possible that meeting all the requirements is that x and y have a common effect z. In this case, we can predict the distribution of z through the same method described in the variable elimination example. So we can get the PZ, the marginal distribution of z. In condition 3, it is required that x and y are independent in both the conditions of Z and an empty set. So in this case, only one that meeting the requirement is x, y, z are independent. And also in this case, that py is independent of the distribution of x and distribution of y. So it's just simply a sum over of x and y over all the situations. This is a more complicated case. We have 4 variables, and we are going to review a different situation of D-separation. In the common effect, if the effect variable has a decedent, if the decedent is given, but the effect variable is not given, then the path is still active. So in our situation, let's look at the first DAG. So x and y is inactive because x, Z, and W, the triple, is inactive. And then in the second case, when Z is given, because the triple Z, W, Y is inactive, so the path of x, y is still inactive. And then the third requirement equal to see whether given y, x, and w are independent. So if we look at the third DAG that y is given, then x and w are independent because of the xcw triple. So we have meet all the requirements. Then let's look at how to calculate the distribution of W. Using the same method, we can eliminate the variables x, y, and z. So we can get 2 distributions of W. First is F2W, and then the other one is based on F3W. So F2W is actually the distribution of based on the course, like based on y, and the F3 is based on the effect, which is based on the z. By doing the renormalization of F2 and F3, we can get 2 distributions of W. Now let's look at condition 5. So the only one that meets the requirement is that Z is independent of everyone, and then X and Y are have the common effect of W. And to calculate the distribution of W, we use the same method that given in the variable elimination example. So that's all. Thank you.